Welcome to Probability at 2 a.m., where CramCart delivers coffee, ramen, and, more importantly, one fast way to stop probability notation from ruining your finals week. We will use one tiny story to make 4 big ideas feel much less mysterious. Meet CramCart, the fictional hero of finals week. It delivers coffee, ramen, chargers, and the confidence to open the assignment you have been avoiding. We randomly inspect 100 CramCart orders. Those 100 possible outcomes are our sample space. Let event A mean that an order includes coffee. Let event B mean that an order includes ramen. Keep those 2 labels in view. They are the whole cast of today's drama.
Here is the data board. Out of 100 orders, 55 include coffee, 40 include ramen, 20 include both coffee and ramen. That leaves 25 with neither. The labels are deliberately bold. A equals coffee and B equals ramen. We will revisit this same group of 100 orders from several angles, so the numbers stay fixed while the probability idea changes.
First, the complement. A complement means every outcome that is not in the event. A complement, written A superscript C, is every order that does not include coffee. Since 55 orders have coffee, 45 do not. So the probability of a complement is 45 out of 100, or 0.45. The key rule is the probability of A plus the probability of a complement equals 1. Every order is either in A or not in A. Next, union. A union B means A or B or both. In our story, that means an order includes coffee, ramen, or the delightfully ambitious combination of both. Look inside either circle of the Venn diagram. There are 35 coffee-only orders, 20 orders with both items, and 20 ramen-only orders. Together, that makes 75. Therefore, the probability of A union B is 75 over 100, or 0.75. In probability, or includes both. No gatekeeping. Intersection focuses only on the shared middle. A intersection B means an outcome belongs to both A and B. For CramCart, that is an order containing coffee and ramen. The overlap holds 20 orders, so the probability of A intersection B is 20 over 100, or 0.20. A quick translation trick. Union means or, while intersection means and. If you remember that pairing, the notation becomes much friendlier. Now for the addition law, the move that prevents double counting. If we add the coffee probability, 0.55, to the ramen probability, 0.40, we have counted the 20 coffee and ramen orders twice. They appear once in A and again in B. So subtract the overlap once. The general addition law is probability of A union B equals probability of A plus probability of B minus probability of A intersection B. Here, 0.55 plus 0.40 minus 0.20 equals 0.75. Double counting is for taking 2 naps, not probability. There is one useful special case. Events are mutually exclusive when they cannot happen together, so their intersection is empty. Imagine CramCart's prize spinner. On one spin, you can win free boba with probability 0.25, or laundry tokens with probability 0.15. One spin gives exactly 1 prize, so free boba and laundry tokens do not overlap. Since there's no shared middle to subtract, the addition law becomes simple addition. 0.25 plus 0.15 equals 0.40. Here is your late-night cheat code. See A complement? Read it as not A and subtract from 1. See A union B? read it as A or B or both. Then add and subtract the overlap. See A intersection B? Read it as A and B and find the shared middle. Finally, if the intersection is empty, the events are mutually exclusive, so you simply add the probabilities. Ask one question first. Do these events share outcomes? That question tells you whether a subtraction is needed.
That is the whole Cram Cart survival kit. Keep your sample space clear, read union as or, intersection as and count the overlap exactly once. May your Venn diagrams be tidy and your coffee statistically significant.